It begins not with thunder, nor with fire, but with a whisper of light that crossed the distance between stars. In the darkness beyond the planets, in a place where silence reigns and human machines rarely glance, something arrived. Not born of Earth, not sculpted by our sun, not tethered to the familiar currents of our planetary family. It moved with the grace of inevitability, and yet with the strangeness of an intruder, an object whose trajectory could not be traced back to any cradle we knew. The astronomers who later studied it gave it a name, 3I Atlas, the third confirmed visitor from the deep interstellar night. But a name is no answer. A name is only the beginning of a question. The human mind has always been haunted by the notion of outsiders. For centuries, tales were told of comets that blazed suddenly into the sky, omens from realms unseen. They were believed to carry warnings or to announce the turning of great ages. Yet even the most distant comets belonged, in the end, to the gravity of our Sunday. They were wanderers, yes, but they circled a familiar center. This was something else entirely, a fragment of another star's long-lost history. A traveler that crossed the gulfs of space, untouched by any orbit we had charted. And yet, it was not the object itself that would twist the imagination most violently, but the images, the photographs taken as it slipped silently across the lenses of telescopes. Blurry, yes. Distant, yes. But within the pixels of those frames, astronomers noticed something unusual. Lines that bent against the expected, distortions that no atmospheric tremor could explain. A subtle glitch, as though the universe itself had flinched while being observed. Something that should not have been there, embedded in the faint light of an interstellar shard. The first frames reached laboratories and observatories around the world. At first, they were dismissed noise, artifact, a flaw in the pipeline of instruments. But the noise persisted. It whispered from one observatory to the next, from one telescope to another, patterns hidden in starlight. The sense grew that the glitch was not random, but deliberate, that the object was either exposing the fractures in our vision or carrying with it a secret meant to be seen. An object not of Earth, a visitor whose presence can only mean two things. Either our science has overlooked something fundamental about the nature of perception itself, or someone, somewhere, is speaking. The first images arrived in fragments, stuttering through the channels of observatory data pipelines, like faint echoes from a vast cathedral. At first glance, they looked no different than countless other recordings of faint, dim bodies drifting across the heavens. A smudge of light, blurred slightly by the trembling of atmosphere and the imperfections of glass. But those who studied them carefully, pixel by pixel, began to notice something unwelcomed, a ripple that should not have been there. It was the asteroid terrestrial impact last alert system Atlas that first caught the intruder's trail. Designed to detect dangerous asteroids that might one day threaten Earth, its arrays of small telescopes in Hawaii sweep the skies each night, looking for the faint streaks of movement against the starry backdrop. On that particular night, the system recorded a light source that drifted too quickly to be one of the background stars, yet too strangely to be classified as one of our own. A flag was raised, and as is routine, other observatories were contacted to confirm. The first faint images came through soon after, from telescopes in Chile and the Canary Islands. The object, though small and distant, behaved like a body that had never belonged to our solar system. The numbers spoke clearly. Its eccentric orbit did not close, did not bend back toward the sun like an icy comet or a wayward asteroid. Instead, it followed a hyperbolic path, the unmistakable signature of something that had fallen in from the stars and would leave again, never to return. But beyond the orbit lay the photographs themselves. There, in the grain of captured photons, astronomers noticed irregularities, not just the streaking that comes from long exposures, nor the static noise of a faint object at the limits of detection. Instead, there were bends in the light, small but persistent. Certain frames carried smudges that repeated across instruments, as if the image of the object was layered upon itself in multiple distorted copies. Some researchers dismissed them outright as compression errors, as artifacts of digital handling, yet others paused, unsettled by the consistency. For faint as the images were, they seemed to whisper that the object was not only foreign to our sun, but that its light arrived carrying a fracture, a crack in the way photons were bent and translated, almost as though the visitor itself interfered with the act of being seen. The earliest frames were archived, analyzed, and recalibrated. Astronomers applied corrective models, trying to smooth away the errors. But the more they corrected, the more peculiar the patterns appeared, and soon the whispers began. Perhaps the object itself was fine. Perhaps the intruder was nothing remarkable in shape or composition. Perhaps it was our vision, the fragile chain of mirrors, detectors, algorithms that was faltering when faced with something it was not built to witness. For in these first faint images, buried in static, the story of 3I, Atlas, truly began, not just as an object, but as a distortion, a ripple that may have been carved by physics itself, or by a hand far stranger. The moment of naming is always a quiet kind of ceremony, an attempt by humanity to tame the untamable. When the discovery passed review and confirmation, the catalogue officially recognized it. 3I Atlas. The designation itself was sober and precise. 3I marked it as the third known interstellar object, following the now legendary 1I, Oumuamua, and the fiery cometary visitor 2I, Borisov. Atlas paid tribute to the automated survey that first drew its silhouette against the void. But for those who had traced its early trajectory and stared into its corrupted images, the name felt like a cipher, an emblem of something that defied every expectation. The discovery team had not set out to hunt for cosmic anomalies. Atlas, after all, was born of a more practical concern: protecting Earth. Its telescopes were designed not to uncover grand mysteries of cosmology, but to watch the skies for silent rocks on deadly paths. Each night, the system swept through slices of the sky, reducing millions of points of light into streams of data. From these streams, algorithms highlighted the faint motions that betrayed a near-Earth object. The intruder was first noticed in this way, not as a revelation, but as an anomaly in the code. Within days, human astronomers had confirmed that what the algorithms suggested was indeed true. The visitor was moving far too swiftly to be bound to the Sunday. Its velocity alone declared it. This was a body forged in the crucible of another star system, flung outward long ago, now slipping through ours for a brief, impossible encounter. But the drama lay not only in what it was, but when it came. The memory of Oumuamua still lingered heavily in the astronomical world. That elongated, tumbling shard had unsettled scientists with its bizarre shape and unexplained acceleration, sparking endless debates over its nature. Many felt they had been caught unprepared, unable to collect enough data before it vanished into the night. When Borisov followed, more traditional in its cometary nature, some felt reassured. Perhaps Oumuamua was merely a strange outlier, not a herald of deeper riddles. Now came Atlas, unexpected, cryptic, and already behaving in ways that unsettled confidence. A third entry in what was once an empty catalogue. 3 interstellar wanderers in less than a decade, when none had been seen for all of human history before. The odds alone rattled scientists. Were such objects far more common than once believed? Or was something about our age, our instruments, or even our cosmos itself conspiring to reveal them now? As the designation 3I Atlas entered the official record, astronomers exchanged emails and quiet phone calls in the late hours of night. Their tones betrayed both excitement and unease. To the world at large, a new celestial object had been discovered. To those who stared closely at the first blurred photographs, the truth was far stranger. They had not only glimpsed a body from the deep interstellar dark, but perhaps also the first signs of something hidden in the act of perception itself. An interstellar object is not supposed to be seen. That is the quiet, unspoken rule of astronomy. Between the stars stretch gulfs so immense that fragments cast loose into those voids should wander in eternal anonymity, too faint, too fast, and too rare ever to cross our gaze. For centuries, humanity assumed that while planets, comets, and asteroids might form in countless stellar nurseries across the galaxy, the debris they shed into the abyss would vanish forever into darkness. Yet, the 21st century began to dismantle that certainty. First came Oumuamua in 2017, slipping into our solar system like a blade, its velocity and path marking it unmistakably as a traveler from beyond. Then, 2 years later, Borisov brighter, more comet-like, spewing dust and gas as though to remind us that the heavens still held familiar shapes, even when their birthplaces were foreign. And now, Atlas, a third intruder, its very existence mocking the old assumption of rarity. 3 interstellar guests in such short succession seemed improbable, if not impossible. Why are they here now? Perhaps our instruments have finally grown keen enough to catch them. Wide-field surveys, deep digital sensors, algorithms that sift oceans of data for subtle movements. Perhaps they were always there, passing unseen, as countless generations of eyes looked upward with no power to detect them. But some whispered another possibility, that something has changed, either in us or in the universe itself. That the quiet, predictable cosmos we once imagined is not quite so silent, not quite so stable. Astronomers knew how unlikely a sighting was supposed to be. Interstellar debris drifts through space at tens of kilometers per second. To detect such an object requires catching it in the narrow window when it passes through our solar system before it escapes again forever. The odds of seeing one in a human lifetime had once been calculated as vanishingly small. Yet the sky had delivered not 1, not 2, but 3, each bearing its own mystery. For Atlas, the improbability deepened when the earliest orbital solutions came in. Its path was steep, its entry angle sharp, its speed undeniable. A cosmic drifter launched untold millions of years ago, now intersecting Earth's neighborhood as though summoned. It was not the scale of a planet, nor the brilliance of a comet's tail that made it extraordinary. It was its origin, foreign, unbound, carved from the debris of another star's birth and hurled across interstellar night. And so it was declared a cosmic intruder, not a resident of our solar system, not an artifact of the sun's domain, but something wholly other. The kind of object astronomers had long theorized must exist, yet quietly assumed they would never see. To witness it at all was remarkable. To witness it carrying with it inexplicable distortions, glitches in its recorded light, was unsettling beyond measure. For if an interstellar object is nearly impossible to detect, what are we to make of one that announces itself not only with motion, but with anomalies in the very act of observation? Perhaps it was coincidence. Perhaps it was chance. Or perhaps Atlas was not merely a visitor, but a messenger one that arrived precisely because it wanted to be found. The anomalies began as whispers in the data. To most, the photographs looked like any other, a faint streak of light against the star field, its shape blurred by distance and motion. But to the trained eyes of astronomers who had spent years coaxing truth from noise, something seemed wrong. Certain images carried distortions that could not be explained away by turbulence in Earth's atmosphere or minor flaws in a telescope's optics. The visitor did not merely blur, it bent. On the first night, when the Atlas system captured its trail, the irregularities were dismissed as coincidence. Detectors can overheat, algorithms can misfire. The digital translation of photons into pixels always leaves scars, small fractures, along the chain of measurement. Yet when telescopes at other sites turned their mirrors to the object, the same distortions appeared again. Not identical, but eerily consistent, as if the universe itself had printed a signature across its light. Astronomers refer to these as glitches because the term is disarming, technical, almost casual. But in truth, what they saw was unnerving. Lines around the object appeared doubled, as though the image were reflected in itself. Faint lattice patterns rippled through the light curve, as if the photons had been diffracted through some unseen grid. At times, the object's core appeared slightly displaced, as though two copies of Atlas were layered imperfectly atop each other, one real, one spectral. Software engineers combed through the data pipelines, searching for compression errors or corrupted storage. Observatory teams recalibrated their instruments, cleaned their sensors, checked their mirrors. Nothing revealed the source. The distortions persisted. When independent observatories reproduced the same anomalies with different hardware, the situation grew more troubling. It was not a quirk of a single telescope, it was something carried within the light itself. To the outside world, reports of 3I Atlas spread as another exciting discovery, a third interstellar visitor joining the brief lineage of Oumuamua and Borisov. Headlines celebrated the rarity of the sighting, but within professional circles, the conversation quickly shifted. A sense of unease deepened. If the distortions were real, then Atlas was not only another visitor, it was something stranger, something that warped the very act of being seen. Some dared to compare it to optical illusions in deep space astronomy, where gravitational lensing bends light around massive bodies. But Atlas was small, too small to exert such influence. Others invoked detector errors, cosmic rays, striking sensors, or software bugs. Yet no correction fully erased the pattern. The glitches seemed to cling to Atlas like an aura, repeating across nights and instruments, like a message carved into the photons themselves. And so the question arose: were astronomers witnessing an interstellar object, or the fracture of perception itself? The photographs should have been silent, a mere confirmation of trajectory and brightness. Instead, they introduced a note of dissonance, like a crack in the lens of reality. If Atlas had simply been a faint blur, it would have passed into history as another rare interstellar shard. But those distortions ensured otherwise. They transformed the object into a riddle, an intruder whose light seemed to glitch, as if reluctant to reveal its true form. Patterns, by their nature, refused to be ignored. Random noise drifts without form, dissolving under scrutiny. But the distortions linked to Atlas carried a persistence that unsettled even the most cautious observers. When researchers overlaid separate images, taken from different telescopes on different nights, faint symmetries began to emerge. The distortions were not scattered or chaotic, they repeated. At first, it was subtle. A faint doubling of the object's silhouette appeared at nearly the same angular offset in exposures taken hours apart. Later, lattice-like ripples traced themselves across frames from distant observatories, aligning far too cleanly to be coincidence. When astronomers subjected the light curves, the fluctuating brightness patterns to deeper analysis, they found harmonic intervals, as though the photons themselves pulsed with rhythm. Such consistencies terrified those who noticed them. In astronomy, pattern is meaning. Stars pulse with predictable periods because of their inner physics. Gravitational lenses repeat because of the geometry of mass. Random cosmic rays striking detectors do not conspire to trace regular grids across multiple instruments. And yet, with Atlas, the distortions followed a script. The community hesitated. To announce such anomalies publicly was to risk ridicule, to invite accusations of wishful thinking or error. Many remembered Oumuamua, whose elongated shape and unexplained acceleration had already sparked whispers of artificiality. The scientific world had recoiled, branding such speculation premature, ungrounded, even dangerous. Few wished to endure such scrutiny again. Still, the evidence whispered relentlessly. Teams began to compare notes in private, sharing raw images before they were processed. To their unease, the distortions were not confined to a single band of the electromagnetic spectrum. Optical telescopes recorded them. Infrared instruments hinted at similar anomalies. Even faint radar echoes carried irregularities that defied calibration. It was as if the visitor was wrapped in a veil, a fabric of interference that imprinted itself upon every attempt to see. Some likened it to the way light fragments, when passing through a diffraction grating, spreading into ordered bands. But there was no grating, no structure known that could explain why Atlas seemed to scatter its own photons into repeating motifs. The possibility that emerged was unsettling. Either the distortions reflected a flaw deep within our observing systems, errors so fundamental that every telescope replicated them, or they revealed a hidden property of the object itself, a design embedded in its interaction with light. The repeating structures were catalogued, logged as patterns of distortion. Some called them glitches, others signatures. A few, whispering late at night, dared to call them signals. But even those who resisted such speculation admitted one thing: randomness had been ruled out. Something in the light of 3I Atlas was speaking with consistency. Whether it was the voice of physics or of something far stranger remained unknown. And so, across observatories, scientists stared longer at the faintest speck, tracing the uncanny order that lingered within its blur. A pattern was there, repeating through the silence of space, waiting to be understood or waiting to be heard. The unease grew not from what was known, but from what seemed impossible, for in the patterns etched into the light of Atlas, certain rules of physics rules, thought inviolable, appeared to bend. Light, when traveling through the vacuum of space, is supposed to be pure, unbroken, obedient only to geometry and gravitation. A photon departs a star, crosses endless miles of emptiness, and is altered only by the known forces of the universe. It does not fracture. It does not repeat itself in harmonic intervals, and yet the photons from Atlas arrived fractured, as though the cosmos itself had whispered something into their flight. Astronomers tried to classify the distortions using familiar tools. Perhaps they were the result of atmospheric scintillation, the shimmering that bends starlight as it passes through Earth's unsteady air. But the distortions persisted across instruments above the atmosphere, captured even by space-based sensors. Could it have been gravitational lensing, the warping of light by the presence of hidden mass along the line of sight? But Atlas was small, its mass negligible, and no great object lay in its path. Could it have been instrumental interference, the flaw of silicon detectors registering phantom signals? Yet the distortions were eerily consistent across instruments built by different hands on opposite sides of the world. This left a darker possibility, that Atlas itself was the cause. Its light appeared to carry an imprint not of randomness but of structure, as if embedded with information. A natural rock, cast adrift between stars, should obey the silence of physics. It should reflect sunlight, emit no strange signature, and pass unnoticed but for its trajectory. Instead, Atlas bent expectation. Its very visibility seemed an act of defiance. The rules of orbital mechanics were another stage upon which the anomaly played. Objects of interstellar origin follow clean hyperbolic paths. They enter, they arc, they leave. But Atlas resisted easy prediction. Small shifts in its position seemed to defy calculation, as though hidden forces tugged upon it. Models disagreed, trajectories diverged. Some solutions placed its exit far from the expected path, suggesting non-gravitational acceleration. The echoes of Oumuamua grew louder, for it too had seemed to accelerate without cause, as though nudged by an unseen hand. The scientific community had always embraced mystery as the doorway to discovery, yet the strangeness of Atlas brought with it something more unsettling, the spectre of violation. For if the distortions were real, they hinted at a physics not yet written in any textbook. They mocked the completeness of known laws, hinting that the fabric of observation itself might be warped by the object's presence. What rules, then, were being broken? That light is unaltered in the void, that orbits obey only gravity and pressure. That information cannot ride upon photons unless encoded by a conscious mind or scattered by known matter. Atlas seemed to challenge all three. It was either a natural object wrapped in unknown physics, or it was something else entirely, an object shaped not by chance, but by intent. And so the fear began, that Atlas was more than a shard of interstellar stone, that it was, in some unfathomable way, a mirror held up to our laws of nature, showing us the cracks we had long refused to see. The mind of astronomy could not look at Atlas without recalling a shadow that had come before. Just 6 years earlier, a different object had sliced through the solar system and ignited a storm of wonder and unease. Its name was Oumuamua, the first interstellar object ever confirmed. Unlike Atlas, Oumuamua was seen late, already receding from the sun when astronomers turned their instruments toward it. What they found in those fleeting weeks was enough to leave scars on science itself. Oumuamua tumbled strangely, its shape unlike anything familiar, elongated, flattened, perhaps cigar-like or disc-like, its silhouette shifting depending on the model. It lacked the shining coma and tail that comets should carry when heated by the sunday. And yet, when its orbit was calculated, it was found to be accelerating ever so slightly, as though some hidden force pushed it outward. Not gravity, not ordinary solar radiation pressure, but something no one could explain. For months, the community wrestled with the anomaly. Was it a shard of frozen hydrogen, sublimating invisibly? Was it a fractal of ice and dust, light enough for sunlight itself to nudge along? Each theory felt fragile, stitched together with uncertain math. And always, lurking in the background, was a more dangerous speculation, that Oumuamua was not a rock at all, but an artifact. A probe, perhaps, or a fragment of alien engineering adrift between stars. When 2I Borisov followed 2 years later, it seemed to soothe those fears. Borisov looked every bit the comet bright, trailing dust and gas, behaving like an ordinary body from an extraordinary birthplace. Astronomers breathed easier. Perhaps Oumuamua had been an exception, a strange outlier. Perhaps the universe was not so intent on unsettling us. But then came Atlas, the third visitor, marked again by anomalies. Though not as visually strange as Oumuamua, its glitches in light reopened the wound. The community remembered too vividly how the world had seized upon Oumuamua, how debates had spilled from peer-reviewed journals into headlines and op-eds, each clashing over whether to even mention the word artificial. Few wanted to repeat that maelstrom. And yet the similarities gnawed at them. Another interstellar visitor, another object that refused to obey expectation, another riddle cast into our skies. In whispers, scientists admitted what they feared. Atlas was a reminder that Oumuamua's story had not ended. It was not an isolated accident, not a one-time curiosity to be filed away in the archives of celestial oddities. Instead, it was a herald of something larger, something repeating. The patterns in Atlas's light bore no direct resemblance to Oumuamua's unexplained acceleration, but the resonance was undeniable. Both mocked the boundaries of known physics. Both appeared uncooperative, as if deliberately eluding simple explanation. And both had arrived not in the distant past, but now, in our era, as though timed for human eyes to notice. What if Oumuamua had been the first whisper, and Atlas the second? What if the universe was not only allowing such objects to drift into our sight, but orchestrating their arrival? To some, this was merely poetic speculation. To others, it felt like an omen that interstellar space was not as silent as we once believed, and that something beyond was beginning to speak. Atlas was not just itself, it was the memory of Oumuamua reborn, carrying forward a question that had never truly been answered, and it asked, with quiet insistence, how many more are yet to come? To uncover an object's truth, astronomers often turn to its spectral fingerprints, the unique signatures carved into light as it reflects or emits radiation. Each element in the cosmos absorbs and emits light at specific wavelengths, leaving patterns of lines like barcodes across the spectrum. With these barcodes, scientists can identify chemical compositions from across unimaginable distances. A comet's icy gases betray themselves. A rocky asteroid reveals its mineral blend. Even the atmospheres of faraway planets whisper their secrets through spectrum. When the first spectra of 3I Atlas were gathered, expectations were simple. If it behaved like a comet, traces of water, vapor, carbon compounds, or dust would appear. If it were an asteroid, the lines of metals or silicates would dominate. And yet, when the data returned, it carried a silence that felt deafening. The fingerprints were incomplete. The spectrum was flatter than expected, lacking the familiar peaks that would announce volatile ices. It resisted easy classification. Some instruments suggested faint hints of carbonaceous material, but others contradicted them. No strong emission lines revealed themselves. No clear absorption features stood out. Atlas's spectrum was less like a barcode and more like a page erased by unseen hands. This lack of signature was itself suspicious. A natural body, especially one warmed by the sun as it swept close, should have revealed something: an outgassing, a release of dust, a clue to its birth. But Atlas, though foreign, wore a cloak of obscurity. It revealed almost nothing of its inner substance. The anomalies in its photographs only deepened the puzzle. Some researchers speculated that the distortions in light could themselves interfere with spectral analysis, corrupting the data, scattering photons in ways that concealed the object's true chemical fingerprint. If that were the case, then Atlas was not simply a rock or a comet, it was an object actively resisting classification, hiding its identity beneath a veil of fractured light. The silence of its spectrum led to two divergent interpretations. Some argued that Atlas might be composed of exotic material elements or structures not common in the solar system, perhaps formed in the violent heart of another star. Others feared a more unsettling conclusion, that the spectrum was not absent but disguised, encoded into the very distortions that appeared as glitches in its images. If so, then what astronomers had dismissed as noise could in fact be the deliberate masking of a message. For a spectrum is not merely science, it is identity, a cosmic fingerprint. Every object has one, every star, every world, every shard of matter. But Atlas, drifting across the sky, carried one that refused to be read. It was as though the universe had presented a book whose pages appeared blank, daring us to admit that we could not yet read the language. The mystery deepened. Atlas was not only strange in its trajectory and its images, it was chemically mute, silent when it should have sung. And in that silence, astronomers began to hear something louder than words, an echo of intent, or a reminder of the limits of human sight. The motion of an interstellar body is supposed to be a clean equation. From the moment its path is traced across the night sky, Newton's and Einstein's laws can predict its trajectory with exquisite precision. Gravity curves its arc, solar radiation adds a gentle nudge, and the mathematics unfold in smooth, predictable lines. Yet 3I Atlas did not behave with such obedience. Its path across the heavens resisted tidy calculation. The earliest orbital solutions diverged. Astronomers plotted its course using the first nights of data, projecting where it would appear in the days to come. Yet when telescopes returned to its predicted location, Atlas seemed displaced sometimes by fractions of an arc-second, sometimes more. These were not catastrophic errors, but they were stubborn, persisting even as more data was gathered. The margins of uncertainty did not collapse as expected. Instead, they widened. This resistance to prediction carried troubling echoes of Oumuamua. That earlier visitor too had broken from a purely gravitational orbit, slipping away from the sun with an unexplained acceleration. Astronomers struggled to explain it. Was it sublimating hydrogen ice, invisible but forceful? Was it radiation pressure acting on an object thin as a sail? Or was it something altogether outside natural expectation? With Atlas, the same unease returned. The small deviations in trajectory might have been explained by outgassing, the jets of material that comets release when warmed by the sunday, but Atlas revealed no coma, no visible trail, no evidence of venting. Its spectrum was silent, its surface mute, yet its course refused to stay steady. It was as though invisible fingers pressed against it, nudging it in ways that evaded clear detection. The more the models were refined, the more fragile they became. Computers churned through the data, running simulations of millions of possible orbits. Yet even with vast computational power, no consensus emerged. Each projection seemed to diverge slightly, as if the object carried an uncertainty field around it, a haze that confounded attempts to pin it down. Some suggested subtle interactions with solar wind, or an unusual surface that reflected light asymmetrically, creating tiny but persistent pressures. Others dared to whisper of gravitational influences from bodies not yet detected, hidden companions, dark fragments. A few speculated in silence about unknown physics, forces that only revealed themselves in the presence of such interstellar wanderers. What unsettled the astronomers most was not the magnitude of the anomaly, but its persistence. It is one thing for an object to slip once from expectation. It is another to resist, night after night, every attempt to anchor it. The trajectory of Atlas became less a path than a riddle, one that mocked every attempt to solve it. And so the phrase spread quietly through observatory halls: trajectories impossible to chart, a body whose future position could never be fixed with certainty, whose course seemed to rewrite itself as it flew. In a universe governed by the strict laws of motion, Atlas moved like something that refused to be bound, an intruder whose orbit was not merely hyperbolic, but elusive, as though it wished to remain ungraspable, forever just beyond the reach of calculation. Silence can be as haunting as sound. For every new object that brushes through our solar system, astronomers and engineers listen not with ears, but with instruments tuned to the whispers of the cosmos. Radio arrays search for faint emissions, radar pulses bounce across the void, particle detectors wait for unusual traces. Even when a body is thought to be inert, the act of listening is ritual, a way of testing whether the universe has hidden intentions. With 3I Atlas, the ritual was performed as always. Dishes of the Very Large Array swept the sky, searching for any radio noise. Radar from facilities in Arecibo's memory and Goldstone's endurance probed its surface, trying to paint an echo from its passing. Deep space sensors accustomed to detecting spacecraft and near-Earth asteroids were directed toward it, and yet, Across the spectrum, the result was the same: silence. This was not unexpected. Most natural objects are radio quiet, offering nothing but reflected sunlight and the occasional whisper of charged particles. But here, silence carried a weight. For the distortions in the images, the anomalies in trajectory, the flatness of its spectrum, all of it had created anticipation. If ever there were an object that might betray a hidden voice, Atlas seemed the candidate. Yet no signal came. What unsettled the scientific community was not the absence of noise, but the absence of explanation. Radar returned only weak, inconsistent echoes, as though the surface absorbed rather than reflected. Radio telescopes recorded faint fluctuations, but they did not resolve into meaningful emission. The detectors that might have caught ionized trails or charged particle bursts registered nothing distinguishable. Atlas was there, undeniably traced against the stars, yet in every channel of listening it refused to answer. Some began to suspect that the silence itself was a kind of anomaly. For radar, reflections should not vanish so completely. Even porous comets and dark carbon asteroids yield echoes. Was the surface unusually absorbent, composed of exotic material that swallowed incoming energy? Or was the interference in its images somehow entwined with its ability to hide from other instruments? A rock drifting between the stars could be dark. But could it be so dark that it refused not just light, but every attempt at detection? The metaphor spread among those studying it. Atlas was a ghost object, seen faintly in distorted vision, but invisible to every other sense. Its silence was not the calm absence of activity, but the silence of something refusing to be touched. The search for structured signals continued anyway, if only out of duty. Algorithms combed the background noise for patterns, for pulses that might betray artificial origin. Fourier transforms were applied, scanning for periodicity, but the results collapsed back into randomness, leaving no melody beneath the static. And so the unease deepened. A visitor had come from beyond the stars, marked itself with fractured light, defied prediction in its orbit, and yet, when pressed for further answers, it gave nothing. No echo, no radiation, no voice. It was present, yet absent, real, yet elusive. And in that emptiness, astronomers found themselves staring at a darker possibility, that Atlas was not only beyond understanding, but perhaps beyond detection itself, a body that existed at the very edge of what human instruments could touch. It was not just silent, it was silence embodied. Each night the object returned, sliding across the sky, the record of its passage carved into long exposures and raw data streams, and each night the list of peculiarities grew. What had begun as a faint distortion in photographs was no longer just an isolated quirk, it was becoming a constellation of anomalies. The first observers had whispered of glitches in the image. Now, after dozens of observatories had turned toward it, the anomalies appeared in multiple forms. Some nights, the object seemed to split itself into two blurred points, faintly doubled. On others, its brightness fluctuated more dramatically than expected, pulsing as though its surface reflected sunlight in patterns far too sharp for a tumbling shard of rock. Certain instruments recorded erratic polarization, the angle of light twisting in ways that suggested scattering from structured surfaces rather than the chaotic irregularities of ice and dust. And then came the strangest finding of all: faint, repeating oscillations in the light curve. At first, they were assumed to be the result of rotation. Many asteroids flash brighter and dimmer as they spin. But the oscillations in Atlas did not match the clean rhythm of a rotating body. Instead, they carried overlapping frequencies, rising and falling like chords struck upon a hidden instrument. They repeated with uncanny persistence, not perfectly, but close enough to resist dismissal as random fluctuation. The anomalies were no longer isolated curiosities. They were accumulating, compounding. Each layer of observation introduced another puzzle, and rather than resolving, the puzzles multiplied. To study Atlas was to wade deeper into a labyrinth where every turn revealed not clarity, but further strangeness. Privately, scientists began comparing notes that never reached official papers. Some worried that even to acknowledge the full scope of the anomalies might tarnish reputations. The history of astronomy is littered with claims of signals, illusions, and mistakes later explained by mundane causes. And yet, in whispered conversations after conferences and late-night emails across continents, the phrase repeated itself. It's not just one thing. Indeed, it wasn't. Atlas's refusal to conform was not confined to one domain of observation, it bled into everyone. Its images distorted, its spectrum muted, its trajectory wavered, its radar echoes vanished. Its light flickered with suspicious order. Each anomaly, taken alone, might have been explained away. Together, they began to feel like evidence of a single, deeper mystery, one whose outline had not yet been drawn. As the data piled up, so did the unease, for science thrives on patterns that can be explained, on puzzles that can be solved. But Atlas was becoming something more unnerving, a pattern of mysteries that refused to resolve, a visitor whose very existence seemed designed not to inform, but to provoke. The astronomers had expected to glimpse a fragment of another star system. What they found instead was a mirror held up to their own instruments, their own assumptions, their own fragile understanding of reality. Atlas did not merely pass through space, it passed through certainty, leaving fractures in its wake. The anomalies multiplied, and with them, the realization spread. Whatever Atlas was, it was not content to be ordinary. In the official reports, the language remained cautious. Words like artifact, calibration error, unresolved discrepancy were deployed as shields, veiling the intensity of what was truly unfolding. But behind closed doors, in dimly lit conference rooms and encrypted message threads, the atmosphere was far less restrained. The scientists who had watched Atlas day after day, who had compared images, spectra, and trajectories, could no longer deny that something was deeply wrong. It was not a single inconsistency they faced, but a storm of them, and the storm was not abating. Each new night of observation only widened the rift between expectation and reality. The anomalies, once thought temporary, seemed persistent, even deliberate, a faint doubling in the image here, a shifting polarization there, an acceleration that refused to map neatly to cometry models, a spectrum that revealed nothing but blankness. The pattern, if it could be called one, was of relentless resistance to explanation. Within the inner circles of astronomy, debates turned sharp. Some argued fiercely that the distortions were errors in observation, subtle weaknesses in detectors and algorithms, masquerading as cosmic strangeness. To admit otherwise, they warned, would open the door to wild speculation, to the kind of media frenzy that had followed Oumuamua. But others pointed to the accumulation of data, the repeated anomalies across independent observatories. They insisted that the phenomenon could not be reduced to mere error. Too many instruments, too many nights, too many voices were echoing the same discomfort. The tension was not only scientific, it was personal. Careers hung in the balance. To claim discovery of a phenomenon that violated established physics was to risk ridicule, to be branded reckless or deluded. Yet, to remain silent while the data spoke louder each night was to betray the very spirit of science. More than one researcher confessed privately that they felt trapped, unable to choose between the safety of skepticism and the peril of honesty. And so, in those hushed rooms, the debates turned urgent, sometimes desperate. Some clung to conventional explanations: detector saturation, cosmic rays, striking sensors, subtle flaws in software pipelines. Others leaned toward the unsettling: gravitational effects not yet understood, properties of matter not yet catalogued, or in whispers they scarcely dared to utter the possibility of deliberate design. What gnawed at all of them was the same truth: the models could not hold. Every theory tested against the data eventually fractured. Like a stone cast into glass, Atlas shattered assumptions wherever it was measured. In the halls of academia, where calm detachment is the norm, there began to circulate a mood closer to dread. Some spoke of sleepless nights, haunted by the thought that Atlas was showing them something the universe had long concealed, something human minds were not ready to face. Others felt exhilaration, as though standing at the threshold of a revelation. But whether fear or excitement, the feeling was the same. The ordinary boundaries of science were being stretched until they threatened to break. Thus, the phrase began to appear in private notes and late-night conversations: "We don't have a model for this." And in that admission lay both terror and wonder-terror that the very foundation of astronomy might be incomplete, and wonder that Atlas, a lone visitor from the stars, might be the messenger of that truth. The debates, though fractious, eventually circled toward a narrowing conclusion. For all the noise and data, for all the distorted images and broken predictions, there came a sobering recognition. There were only two possible explanations for what Atlas was showing. Not a dozen, not a catalogue of vague, maybe theories, but two stark interpretations, each profound, each unsettling. The first: the glitches belonged to us. That somewhere in the long chain from starlight to human eye, our instruments had faltered. That the mirrors, detectors, software, and algorithms upon which modern astronomy depends were introducing illusions, artifacts, mistaken for signals. In this view, Atlas was merely a mirror reflecting our technological imperfections, revealing the fragility of perception when stretched to its limits. It was not the object that was strange, but us. The second: the glitches belonged to it. That the distortions were not accidents of vision but features of the object itself. That Atlas carried within it a structure, a design, or a property of matter so alien it interfered with the very act of seeing. In this view, the interstellar traveler was not only an outsider to our solar system, but perhaps an outsider to our understanding of nature itself, an emissary of something beyond. Both possibilities were terrifying in their own way. If the fault lay in our instruments, then the tools upon which we have built our understanding of the universe might be more fragile than we ever admitted. If the fault lay in the object, then it was no mere shard of stone but something deliberately enigmatic, something that spoke through distortion. The more the community circled this binary, the more it hardened. Every fresh dataset seemed to fall inevitably toward one of the two poles. Either the anomaly was an illusion woven by our perception, or it was a signal woven by something else. Some called it a cosmic trick, others a cosmic test. But in both camps, the mood was the same. The universe had forced them to the edge of reason. Atlas could only mean two things, and each was a door into the unknown. The astronomers, weary from sleepless nights, began to articulate the tension aloud. In meetings, the phrase was repeated with quiet gravity: "It must be one of these two." And in the silence that followed, no one spoke of which answer they feared more: that the cosmos was mocking the trustworthiness of human sight, or that it was speaking in a language designed never to be ignored. The first of the two possibilities was, in many ways, the most comforting: that 3I Atlas was revealing not a cosmic truth, but a human flaw. The cosmic error hypothesis, as some quietly called it, proposed that the glitches in its light were nothing more than reflections of our own imperfect machinery. Science, after all, is built on layers of mediation. Light leaves a distant object, traverses the void, slips through the trembling atmosphere, reflects across mirrors, strikes detectors, and is translated into electrical signals. Those signals pass through cables, processors, and algorithms before being rendered as images on human screens. At every stage, there is room for error. A misaligned mirror, a pixel bleeding charge into its neighbor, a rounding mistake in code, each has the power to seed illusions. Perhaps Atlas was simply faint enough, distant enough, and strange enough in its motion to expose cracks in this chain. Perhaps its photons, arriving in small numbers, tested the limits of our instruments in ways no ordinary object had. To the cautious mind, this was the simplest explanation. The distortions were not the object's fault, but ours. Examples abounded from the history of astronomy. There was the canal illusion of Mars, born from overstrained eyes and imperfect telescopes. There were phantom stars catalogued in the 19th century, later revealed to be defects in lenses. There was the famous "wow" signal of 1977, a burst of radio energy once thought to be a message from the stars, later suspected to be an earthly interference. Again and again, nature had punished human eagerness with the cruel trick of error. Why should Atlas be any different? To those who favored this hypothesis, the case was simple. The glitches could not be trusted. They were systematic flaws in data acquisition, calibration oversights, or misinterpretations amplified by expectation. The more telescopes turned toward Atlas, the more chances there were for flaws to appear. The repetition of patterns across instruments, they argued, only proved that the same assumptions and pipelines were being applied everywhere. The consistency was not cosmic, it was cultural. And yet, even among the proponents of error, unease remained. For the anomalies were too persistent, too resistant to elimination. Software engineers patched algorithms, astronomers recalibrated optics, analysts applied new correction filters. Still, the distortions remained, like stains that refused to wash out. If it were error, it was an error woven deep into the fabric of our observational system, so deep that every tool shared it. This realization darkened the hypothesis, for if Atlas had revealed cracks in the foundations of astronomy, then the implications were staggering. The billions of observations built upon these methods might all harbor unseen distortions. Our maps of galaxies, our surveys of exoplanets, our measurements of dark matter, all of it could contain echoes of the same flaw. The comforting hypothesis, when stretched, became nearly as terrifying as the alternative. Perhaps Atlas was not a message from the stars. Perhaps it was worse. A reminder that our instruments could not be trusted, that the window we had carved into the universe was warped, and that for all our precision, we were still staring at shadows on a wall. If so, then Atlas was not an alien messenger, but a teacher, one that forced us to admit the fragility of human perception. A cosmic error, yes, but one with consequences that reached far beyond a single object. The second possibility was the one many feared to name aloud, for its implications rippled outward like a chill across deep water. If the glitches in Atlas's light were not artifacts of human perception, then they belonged to the object itself. They were not flaws, they were features. The distortions might not be errors at all, but deliberate structures, patterns etched into photons like grooves into a record. The phrase surfaced quietly, then spread in private. Engineered signal. At first, the idea was dismissed outright as reckless speculation. No scientist wanted to relive the turbulence of Oumuamua when headlines had leapt to alien hypotheses before the data had settled. But the patterns in Atlas's distortions were not so easily waved away. They persisted, repeating across instruments and across nights, their order too stubborn to be discarded as coincidence. If intentional, what was their purpose? Some imagined a beacon, a universal call encoded not in radio waves, but in the very distortion of reflected light. Such a choice, if deliberate, would be elegant. Unlike radio signals, which scatter and fade across interstellar distances, light is everywhere, the natural messenger of stars. Any civilization with the ability to engineer material at the smallest scales could, in theory, sculpt a surface to scatter photons in specific patterns, embedding information into every glimmer. Others pushed the speculation further. What if Atlas itself was not a random shard of interstellar debris at all, but a device? A probe launched into the abyss, its trajectory chosen to intersect solar systems, its silence broken only by those who possess the tools to see. Its lack of spectral fingerprint could then be explained as design, its anomalous motion as controlled. The glitches would not be flaws, they would be language. The thought was intoxicating and terrifying, for to interpret the distortions as a signal was to imagine intelligence older, greater, and vastly more capable than humanity. An intelligence that could fling objects across interstellar gulfs and encode messages in the scattering of starlight. The very idea brushed against the edges of human imagination, straining it to breaking. Skeptics countered that such a notion was more dangerous than any error hypothesis. It risked drawing science into myth, turning anomalies into evidence for fantasies. But even they could not explain the persistence of the patterns. They offered models of noise, of interference, of unknown natural physics, but the word signal lingered, unspoken yet unavoidable. The engineered signal hypothesis did not demand belief, it demanded fear. Fear that the universe was not silent, fear that something somewhere had already reached across the stars, and that Atlas was its messenger. Fear that we were not alone, and that the message being delivered might not be for us, but simply visible to us as it passed. Thus, the second possibility stood opposite the first like a mirror. Either the glitch revealed the weakness of human perception, or it revealed the presence of something beyond it. Both possibilities were destabilizing, but only one carried the weight of intention, the possibility that Atlas was not simply passing through, but speaking. And the silence that followed in conference rooms was heavy, for if it was speaking, what exactly was it saying? When faced with a mystery that bent light itself into impossible shapes, many wondered what Einstein would have said. For it was Einstein who taught the world that light is not merely illumination, but geometry incarnate. In his theory of general relativity, light is never free. It travels along the curves of space-time, bending around stars, stretching with the expansion of the cosmos. Light reveals gravity not by words, but by its path. Perhaps then, the strange distortions of Atlas were not signals or errors, but echoes of relativity taken to extremes. Could it be that Atlas drifted through a region of warped space-time, an unseen mass, a pocket of curvature that bent photons into repeating patterns? Might its passage have coincided with a hidden gravitational lens, a stellar remnant, or even a faint black hole whose presence escaped detection? Such possibilities were whispered, yet none fully explained the consistency. Gravitational lensing produces arcs, smears, magnifications, not neat lattices, and harmonic pulses. Others wondered whether Atlas itself was embedded in a fabric of warped space-time. If its matter carried density or structure unfamiliar to physics, perhaps it bent light in ways more delicate than stars and galaxies, producing effects more like interference than arcs. Einstein had shown that space is pliable, a stage upon which mass choreographs light's journey. What if Atlas carried within it a hidden weight, a local knot in the fabric of space, twisting photons as they escaped? The speculation touched deeper questions Einstein himself had wrestled with. Is space-time smooth, or does it fracture into unseen granularity. Quantum mechanics had long suggested that at the smallest scales, space-time might jitter, foam, or flicker. The distortions around Atlas could then be glimpses of this quantum granularity magnified, drawn into visibility by the passage of an object not native to our solar system. The idea was unsettling but strangely poetic, that Atlas might be less an intruder than a lantern, illuminating the cracks in reality itself. Einstein had once called attention to the incompleteness of physics, noting that general relativity and quantum mechanics refused to reconcile. Perhaps this was where their dissonance finally bled into view, not in laboratories or colliders, but in the faint trail of a traveler from another star. And yet, as elegant as these ideas seemed, they faltered before the data. For relativity predicted distortions, yes, but not distortions that repeated across nights, across instruments, across frequencies. Space-time bends light, but it does not hum. It does not create harmonic pulses. It does not inscribe lattice patterns into photons. What Atlas displayed seemed deliberate, even structured, where relativity only offered smooth curves and infinite patience. Still, the ghost of Einstein lingered over every conversation. His voice seemed to whisper in the margins. Light is the messenger of space-time. If it carries a riddle, then space-time itself may be speaking. Whether the message came from geometry or from something that used geometry as its medium, no one could yet decide. But one thing grew clear. If Einstein were alive to witness Atlas, he would have asked not only what bent the light, but who, or what, had placed the mirror there. Beyond relativity, there lies a deeper strangeness, one that Einstein himself resisted, but which modern physics has come to embrace: the restless, seething ocean of quantum fields. To the naked eye, the vacuum of space appears as emptiness, a void through which light travels without obstruction. Yet quantum field theory tells us the opposite. Even the most silent vacuum is alive with fluctuation, particles flickering into and out of being, fields trembling with energy that can never fully vanish. The universe is not still, it hums. Some scientists turn to this hidden hum when wrestling with Atlas. Perhaps the distortions in its light were not artifacts of technology, nor deliberate signals, but interactions with the vacuum itself. A fragment of matter born in a distant star system, moving through space-time at interstellar speeds, could excite the quantum fields around it in ways we do not yet understand. The glitches seen in the images might then be the whispers of the vacuum photons scattered not by dust or atmosphere, but by the trembling of reality's own foundation. One possibility raised was vacuum birefringence, a phenomenon predicted by quantum electrodynamics. In strong magnetic fields, empty space itself can split light into polarized components, bending its path as though the vacuum were a crystal. Such effects are thought to occur around neutron stars, where magnetic fields reach unfathomable intensity. But could Atlas, drifting silent and unassuming, carry within it some exotic property that triggered a milder echo of this phenomenon? Could its mere presence reveal a universe where even emptiness is not truly empty? Others speculated on more exotic grounds. Quantum field theory predicts that the vacuum is metastable, that the universe may one day collapse if a deeper, more stable vacuum state exists. Perhaps the distortions were ripples of this instability, revealed in the presence of matter forged under conditions alien to our solar system. If so, then Atlas was not simply a rock, but a shard of deeper physics, a messenger from a regime where the quantum foam of space ripples differently. The idea was haunting, that Atlas was less a signal and more a mirror, showing us the fragility of what we call reality. For if quantum fields could alter light in ways not yet measured, then our instruments were not misbehaving. They were finally registering truths hidden beneath the calm surface of the cosmos. Yet such interpretations walked the knife edge between science and speculation. To invoke vacuum whispers was to admit how little is truly known. The mathematics of quantum fields is rich but merciless, predicting infinities that must be renormalized away, leaving behind a theory both powerful and incomplete. If Atlas had indeed revealed a flaw or secret in this invisible ocean, then the object was not just a visitor, it was a probe into the heart of reality, one that carried questions humanity is scarcely prepared to ask. And so, the phrase emerged among some theorists, perhaps the vacuum itself is speaking through it, not with intention, not with message, but with the restless truth that emptiness is not empty. Atlas might then be nothing more and nothing less than a ripple in the silence, the whisper of the vacuum caught in the act of being real. If relativity and quantum fields could not fully explain Atlas's strange behavior, another candidate loomed in the background, vast and elusive: dark energy. For nearly a quarter of a century, dark energy has haunted cosmology as the name given to our greatest ignorance, the unseen force driving the accelerated expansion of the universe. We do not know its source, its structure, or even if it is a thing at all. We only know that galaxies race away faster than gravity should allow, as if the very fabric of space is pulling itself apart. Some theorists wondered if Atlas's fractured light might be a trick played by this invisible hand. If dark energy permeates space uniformly, then perhaps its influence is too subtle to detect in any single moment. But what if interstellar objects, crossing regions of space for millions of years, carry with them imprints of its fluctuations like driftwood bearing scars from the tides? Could Atlas, born in another star system and flung across the void, be wrapped in eddies of dark energy that distorted the photons escaping its surface? One model proposed that the equation of state of dark energy, the ratio that defines its pressure to its density, might not be constant. Instead, it could oscillate, leaving interference patterns on any light that passes through its restless fields. If true, then the glitches observed around Atlas were not errors or signals, but cosmic expansion itself written into the object's illumination. The distortions would not belong to Atlas alone, but to the universe entire, briefly revealed in its presence. Others speculated further, imagining that dark energy might create regions of unstable vacuum, microdomains, where the constants of physics shift subtly. If Atlas had crossed such a region in its long journey, it could now carry a halo of altered space-time around it, a bubble of physics out of tune with our own. Light reflecting off its surface would bend and scatter not as photons normally do, but as if refracted through glass from another reality. The idea was as terrifying as it was beautiful. For if dark energy were unstable, then the universe itself was not secure. It might one day tip into a new state, collapsing every atom and every star into a different physics. The anomalies around Atlas could then be a fleeting glimpse of that future, a premonition carried by a visitor from the stars. And yet, as always, doubt gnawed at the edges. Dark energy is inferred only from the grand scale of the cosmos, from supernovae and galaxies, not from local phenomena. To see its hand at work in a single object seemed implausible, even desperate. Critics warned that to invoke dark energy here was to stretch ignorance upon ignorance. Still, the allure of the hypothesis lingered, for it wove Atlas into the deepest question of all. What force drives the universe apart, and what scars does it leave behind? If the distortions of Atlas were truly born of dark energy, then the glitch was not local, not artificial, not error. It was the cosmos itself, revealing that even light cannot cross its distances unaltered. A reminder that expansion is not silent, but leaves behind whispers etched into every photon, waiting for eyes to notice. The most daring speculation of all drew its strength from an idea as vast as it was unsettling: the multiverse. If our universe is not alone but one of many, then the space we see each night is only a sliver of a grander, hidden architecture. Each universe could carry its own laws, its own constants, its own geometry of light. To encounter a fragment from another would be to glimpse beyond the boundaries of what we call reality itself. Some theorists began to wonder if Atlas might be such a fragment, a shard not merely of another star system, but of another universe. The glitches in its light, then, would not be signals or errors, but scars left by its passage across the boundary between worlds. Just as ice cracks when moved from one environment to another, so too might photons fracture when passing from one universe's physics into ours. The concept was not without precedent in theory. Inflationary cosmology, first proposed in the 1982, suggests that our universe is but a bubble in a larger cosmic foam. Other bubbles, expanding in parallel, might occasionally brush against ours. Where boundaries touch, strange phenomena could arise: interference patterns, discontinuities, echoes of other realities. Perhaps Atlas, adrift for millions of years, had wandered through such a frontier, carrying with it the imprint of a collision between universes. One possibility was even more radical: that Atlas itself was not matter as we understand it, but a structure formed under different physical constants. If another universe forged it, its atoms might not align with ours, its fields might not resonate with the familiar rules of electromagnetism or gravity. The distortions in its images, the silence of its spectrum, the unpredictability of its orbit, all could be consequences of this fundamental mismatch. We were not simply observing a foreign rock, we were attempting to perceive something that had no true counterpart in our reality. The philosophical implications were staggering. If Atlas was indeed a multiversal fragment, then its presence shattered the idea of a self-contained cosmos. The boundaries of reality were no longer secure. We would be forced to admit that what we call the universe is but one chamber in an infinite cathedral, and that occasionally debris from other halls drifts into ours, whispering of architectures we cannot yet imagine. Of course, many resisted such speculation. The multiverse, though mathematically motivated, remains controversial, criticized for being unfalsifiable. To invoke it here felt like surrender, as though astronomers had abandoned all earthly explanations and leapt into metaphysics. But the persistence of Atlas's anomalies kept the door open. When confronted with phenomena that resisted every conventional model, the human mind reaches outward, even into infinity, searching for a place where the impossible might make sense. And so the whispers grew. Perhaps Atlas was not only interstellar, but inter-universal, a shard from a place where light and matter obeyed a different grammar, drifting now into ours, warping photons into strange repetitions as they struggled to speak a language we could not hear. If true, then Atlas was more than a visitor. It was a reflection, a reminder that our universe might not be singular, and that reality itself may be porous, bleeding fragments of elsewhere into the silence of our skies. If the distortions were indeed signals engineered rather than accidental, then the next step was obvious: to test them as one would test a code. Across observatories and universities, teams of astronomers, data scientists, and signal analysts began subjecting Atlas's light to scrutiny designed not for comets or asteroids, but for messages. The first tool was the Fourier transform, a mathematical prism that reveals hidden frequencies within a dataset. Applied to the light curves of Atlas, it showed not a smooth, random spectrum, but peaks frequencies that repeated with unsettling regularity. They were faint, buried in noise, but undeniable. To many, they looked like harmonics, the fingerprints of structure rather than chance. Next came pattern recognition algorithms, some borrowed from radio SETI, others from cryptography. They searched for sequences, for repetition that could not be explained by rotation or scattering. A few runs produced tantalizing hints, symmetrical bursts, intervals of brightness that echoed like the beat of a hidden drum. Other runs found nothing, reminding everyone how treacherous it is to interpret faint data. Yet even the negative results could not erase the unease. Some groups tried binary encoding tests, reducing light fluctuations to ones and zeros. The goal was to see whether Atlas's flickering could be arranged into coherent sequences, something more than random. To their astonishment, certain datasets, when reduced this way, produced repeating strings. They were not long, nor did they resolve into language, but they were structured, like the edges of a melody glimpsed in static. Others probed for non-random geometry in the distorted images themselves. By mapping the lattice-like patterns around Atlas, they sought order, angles, ratios, symmetries. A few results hinted at repeating triangular geometries, as though the light had been diffracted through a designed aperture. But skeptics cautioned, human eyes are drawn to patterns, and the cosmos has fooled us before. The canals of Mars, the face on the moon, the wow signal all had once seemed deliberate until they dissolved into error or coincidence. And yet, one fact resisted dismissal. The anomalies were reproducible. Independent observatories, separated by continents, using different instruments, saw the same distortions. That made the signal hypothesis difficult to banish. For noise does not repeat across oceans, coincidence does not synchronize itself across hemispheres. In hushed tones, researchers admitted the gravity of what they were attempting. To treat Atlas's light as a possible signal was to step into dangerous territory, to risk accusations of sensationalism, but the data demanded it. The anomalies refused to vanish, and so the work continued, quietly, carefully, as though decoding a message that might or might not be there. Perhaps it was folly, perhaps it was brilliance, perhaps it was both. For even as they tested, as algorithms churned and models strained, one truth loomed. If the distortions were signals, then humanity was not simply watching a rock drift through space. It was eavesdropping on an intelligence that had crossed the stars, speaking in photons, embedding intention into light. And in that possibility, every faint pixel became a letter, every harmonic a syllable, every glitch a word whispered across eternity. The moment the word artificiality entered the discussion, the community fractured. For decades, astronomers had been conditioned to treat such speculation with suspicion. To invoke intelligence, where natural explanations might suffice, was seen as premature, reckless, even unscientific. Yet the evidence surrounding Atlas, its fractured light, its silent spectrum, its elusive trajectory, forced the question into the open. At first, the idea was only whispered in hallways after conferences or buried in private email threads. Researchers would write, "If it were artificial," followed quickly by long paragraphs of disclaimers. Some mentioned the possibility only to dismiss it, a ritual gesture meant to protect reputations. But slowly, the phrase began to take hold. What if it isn't natural? On one side stood the traditionalists, insisting that every anomaly must yield to physics. They pointed to Oumuamua, which had sparked a media storm when a handful of scientists dared to suggest it might be a probe. Years later, most of the community leaned toward mundane explanations: exotic ice, thin geometry, natural but strange. To leap again to artificiality, they warned, would erode trust, turning science into myth-making. We have not exhausted natural causes, they argued. We must not invoke the extraordinary until the ordinary is broken. But others pushed back. They pointed to the persistence of Atlas's distortions across instruments and continents, to the harmonic intervals in its light curve, to the silent radar echoes that defied explanation. They argued that these were not simply outliers, but patterns consistent, structured, intentional. If we saw this in a radio signal, one researcher remarked, we would not hesitate to call it technosignature. Why then should light be treated differently? The debate grew heated. Some insisted on restraint, fearing the ridicule of colleagues, the intrusion of media sensationalism, the damage to careful science. Others believed restraint had already become denial, a refusal to confront evidence because it carried uncomfortable implications. At times, the conversations took on a near philosophical tone. Was science's duty to protect its credibility, or to follow truth wherever it led, no matter how destabilizing? Into this tension stepped the small but growing field of technosignature research, the systematic study of possible evidence for extraterrestrial technology. Long marginalized, its practitioners suddenly found themselves thrust into relevance. To them, Atlas was exactly the kind of anomaly their discipline existed to investigate. They spoke of diffraction gratings, engineered reflectors, and embedded codes in light. They warned that to dismiss such possibilities was to ignore the very evidence we had spent centuries longing for. And yet, the clash was unresolved. Each side accused the other of blindness, one to the weight of skepticism, the other to the possibility of wonder. Atlas became a battlefield of worldviews. Was it a rock wrapped in unknown physics, or a messenger built by intention? Was caution the wiser path, or was it cowardice disguised as rigor? The arguments echoed in conference halls and across encrypted channels, but always beneath them lay the same unspoken fear. If Atlas was artificial, then humanity was no longer the sole architect of signals in the void. Another intelligence had already reached across the stars, and its message was passing silently before our eyes. Artificiality remained a hypothesis, not proof, but even as the arguments raged, the question lingered in the minds of all who looked upon the distorted light. What if this was the first time the universe itself had spoken back? For every whisper of signal and speculation of intent, there remained a counterweight, the possibility that the anomalies were nothing more than illusions born of nature and machinery. Before humanity could leap to the extraordinary, it was duty-bound to consider the ordinary, however unsatisfying those explanations might seem. Thus emerged a revisiting of the cosmic error hypothesis in greater depth, this time dissected into all its possible guises. The first candidate was gravitational lensing. Light can be bent by mass, even small mass, creating distortions in the images of distant sources. Could Atlas have passed near some unseen body, a fragment, a remnant that twisted its light before reaching us? The trouble was scale. Lensing requires enormous gravity, the weight of stars or planets. Atlas itself was far too small. Unless it carried a hidden mass, orders of magnitude greater than estimated, lensing could not account for the lattice-like ripples seen across its images. Next was detector saturation. Sensitive instruments, when faced with faint moving objects, sometimes produce ghost images. Brightness bleeds from one pixel into its neighbors, duplicating a source or creating apparent patterns. Yet when engineers replicated the observing conditions in simulation, the distortions of Atlas did not behave like saturation artifacts. The ghosts were too regular, too consistent across different detectors. Software misreadings were also scrutinized. The pipelines that transform raw photon counts into usable images are complex, relying on algorithms to subtract noise, calibrate distortions, and align frames. If those algorithms stumbled, they could create phantom structures, but these pipelines were tested repeatedly with other objects, and no similar anomalies emerged. Atlas alone seemed to provoke the glitch. There was also the possibility of cosmic rays striking detectors, injecting false streaks and patterns into the data. Yet cosmic rays are random, their scars inconsistent. Atlas's distortions repeated, night after night, telescope after telescope. Randomness could not explain repetition. Finally, some invoked atmospheric interference. Even with adaptive optics, the Earth's atmosphere can warp and scatter starlight, creating illusions of doubling and blurring. But space-based instruments that observed Atlas above the trembling air recorded the same peculiarities. The sky's turbulence could not be blamed. Each hypothesis was plausible in isolation, but strained when tested against the full body of evidence. Lensing explained bending but not repetition. Detector flaws explained doubling but not polarization anomalies. Algorithms explained artifacts but not harmonic intervals. None could stand alone. Together, they contradicted more than they explained. And yet, many scientists clung to these possibilities, not out of denial, but out of discipline. For to leap past natural explanations was to cross into dangerous territory, where speculation risked outrunning evidence. The history of astronomy demanded humility. Illusions had fooled us before. Perhaps Atlas was only the most elaborate of such deceptions, a trick of circumstance and machinery conspiring to appear meaningful. But even as these alternatives were catalogued and tested, doubt remained. For every natural explanation, there was a counterexample, a dataset that refused to fit. It was as though Atlas danced at the boundary of error and intention, never fully allowing itself to be claimed by either. And so, the cosmic error hypothesis persisted, not dead, but weakened. It remained a shield for caution, a way of reminding humanity that the universe is vast and deceptive, and that the limits of our tools often masquerade as mysteries. Yet beneath the shield, unease grew. For if error could not explain everything, then something else was at play. Something still waiting to be named. The mystery of Atlas did not fade with time. Instead, it drew the eyes of the most powerful machines humanity had yet built for seeing the cosmos. If ordinary telescopes could not pierce the veil, then perhaps instruments on the bleeding edge of technology might. Thus began the campaign to turn our most advanced eyes toward the intruder, to test whether its anomalies could withstand the scrutiny of giants. Foremost among them was the James Webb Space Telescope, JWST, perched 1,000,000 miles away at the second Lagrange point, shielded from Earth's warmth by its golden mirrors. Designed to probe the faintest galaxies at the dawn of time, JWST was also capable of turning its gaze toward closer, smaller mysteries. Its infrared instruments could reveal details invisible to ground-based optics, mapping heat signatures, surfaces, and spectral lines with unmatched precision. When Webb's operators scheduled observations of Atlas, anticipation was electric. If the object was an ordinary shard of ice and rock, JWST would confirm it. If not, the anomalies would either be resolved or deepened. At the same time, preparations stirred at the Vera C. Rubin Observatory, not yet fully operational, but already testing its colossal wide-field eye. The Rubin telescope, with its unprecedented ability to sweep vast portions of the sky, promised to track Atlas's motion in exquisite detail, capturing thousands of images as it slipped through the heavens. Every flicker, every deviation, every whisper of brightness would be recorded, creating a dataset vast enough to reveal rhythms hidden in smaller samples. Elsewhere, Europe's extremely large telescope, ELT, still under construction in the Chilean desert, was already being touted as a future instrument for such enigmas. With a mirror 40 meters wide, it would one day dwarf all predecessors, capable of resolving faint details on interstellar wanderers that now appeared only as blurred specks. Scientists spoke of the day when objects like Atlas could be mapped in unprecedented resolution, their surfaces traced, their compositions laid bare. Even instruments not designed for astronomy joined the effort. Particle detectors were tuned to watch for unusual interactions in case Atlas emitted high-energy particles unseen by ordinary optics. Radio arrays scanned its path repeatedly, searching once more for patterns buried in silence. The Gaia spacecraft, mapping the stars with exquisite precision, was asked to refine Atlas's position, hoping to pin down its errant trajectory. In every case, the goal was the same: to test whether the anomalies persisted under sharper vision. If Atlas was an illusion, it would dissolve under the weight of better data. If not, then each new telescope would carve the mystery more deeply into stone. The early results were mixed. As though Atlas itself resisted resolution, Webb confirmed the flat spectrum, but also recorded faint fluctuations that could not yet be explained. Rubin's trial surveys hinted again at strange periodicities in brightness. Radio searches remained mute, yet not conclusively so. The object continued to slip away, its secrets intact. Still, the effort carried symbolic weight. Humanity was not content to glance and wonder. It was chasing the intruder with its greatest eyes, refusing to let it vanish unchallenged. For even if Atlas passed into the dark beyond, others like it would follow, and the instruments would be ready. Science had entered a new era, the age of interstellar objects, the age when fragments of other suns would become canvases for our deepest questions. Atlas was not the last, but it was the one that forced humanity to admit that the universe might speak in ways our tools are only just beginning to hear. And so the telescopes kept their vigil, patient and unblinking, as though waiting for the visitor to reveal, in one final frame, whether it was a shard of stone or a message carved in light. As the world's most powerful telescopes strained their mirrors toward Atlas, another comparison began to surface, one not of machines, but of journeys. Humanity itself had already sent emissaries into the dark, fragile and metallic, bearing messages across the void. The Voyager probes, launched in the 1,970 seconds, now drift far beyond the planets, their golden records etched with sounds and images of Earth. They were humanity's first whispers to the stars, artifacts meant not for us, but for whoever or whatever might someday find them. The parallels were difficult to ignore. Just as Atlas crossed into our solar system as a mute messenger of another place, so too did Voyager drift outward as a silent envoy of ours. Both moved along hyperbolic paths, destined never to return. Both carried with them information encoded not in words, but in structure. Voyager in its disks, Atlas perhaps in its fractured light. To study the interstellar visitor was, in a way, to glimpse ourselves reflected, to wonder whether our own probes, millions of years from now, might appear to another civilization as a faint, inexplicable glitch in the sky. Some scientists, in quiet moments, allowed themselves to indulge this parallel. Perhaps Atlas was not unique. Perhaps countless civilizations had launched their own voyagers, their own silent wanderers into the dark, leaving behind trails of intention scattered across the galaxy. If so, then interstellar objects might not all be debris. Some could be archives, signals, monuments, cosmic messages adrift, waiting for eyes capable of noticing. This line of thought unsettled others, who preferred to keep the conversation rooted in physics rather than philosophy. But even they admitted the resonance. Humanity had already crossed the threshold of becoming an interstellar presence, however faint. The Voyagers, Pioneer plaques, and New Horizons probe were seeds cast into the abyss. To imagine that another civilization had done the same was not fantasy, it was symmetry. And so the silence of Atlas became even more haunting. If it was a messenger, why did it not speak in clearer terms? Why did it not broadcast a signal, or display markings, or reveal unmistakable evidence of design? Why cloak itself in distortion, ambiguity, glitch? Perhaps because clarity is not the nature of such journeys. A probe flung across the stars must survive ages. Its message, if it carries one, cannot be tailored to any single species, any single moment in cosmic history. It must be as enduring as stone, as cryptic as mathematics, as patient as time. The voyagers themselves remind us of this. Their records, though meticulously crafted, may one day be found by beings whose senses are unlike ours, whose languages are unknowable. To them, the disks may seem as indecipherable as Atlas's flickering light seems to us. Yet meaning might still be there, buried in form, waiting for interpretation. In this reflection, Atlas became not only an enigma, but a mirror. It asked us to look at our own fragile emissaries and admit that the universe may already be full of such whispers, messages wandering, silent and ambiguous, across gulfs too vast for certainty. And if so, then Atlas was not alone. It was part of a conversation humanity has only just begun to overhear, a chorus of voyagers and wanderers singing in silence across eternity. The thought pressed in with quiet weight. What if the glitch is real? Not error, not coincidence, not illusion, but deliberate, a message woven into the light itself. To accept this possibility was to step across a threshold where science blurred into philosophy, where data became dialogue, and where humanity was no longer the sole author of meaning in the cosmos. If the distortions were intentional, then Atlas was not simply a shard of matter, but a construct, a signal bearer, a beacon, or a probe. Its silence in radio, its muteness in spectrum, its refusal to reveal ordinary composition could all then be understood as choices. Its very ambiguity might be the point. For what better way to draw attention than to present a puzzle no natural explanation could fully resolve? The implications were staggering. First, it would mean we are not alone. Not in the sense of microbes hidden beneath Martian soil or primitive organisms swimming in the oceans of Europa, but in the presence of intelligence vast enough to launch emissaries across interstellar gulfs. Such an intelligence would be old, powerful, and deliberate, its engineering capable of manipulating light at scales we barely understand. Second, it would mean we had been noticed. Whether by design or by chance, Atlas had entered our solar system and revealed itself. The distortions were visible only because our instruments had grown precise enough to detect them. This timing might be coincidence, or it might not. If it was deliberate, then the visitor had been waiting for us. Its message designed not for the ancients who watched the sky with naked eyes, but for a species that had finally built machines sharp enough to see the glitch. But most unsettling was the third implication, that the message, if it exists, is not meant to be understood quickly. It may not be a greeting, or a warning, or even something that could be called language. It could be mathematics encoded in light, geometry etched into diffraction, a structure too alien for us to pass in a single generation. Or it could be something more existential, a demonstration that the universe itself can be altered by intention, a way of saying, we were here, we could do this, and so might you. Such a possibility is both thrilling and terrifying, for if the glitch is real, then the human story is no longer confined to Earth or even to the silent stars we see each night. We are part of a larger narrative, one that stretches across time and across civilizations. Our first encounter with alien intelligence may not come as a handshake or a transmission, but as a distortion, an optical puzzle drifting through the dark. And if this is true, then Atlas is not a rock at all. It is a mirror, showing us what intelligence can become: subtle, cryptic, patient. A presence that speaks not in words, but in riddles carved into photons, inviting us to learn, to strain, to wonder. The terror lies in knowing that the message may outlast us, that the signal might remain undecoded long after humanity is gone. But the wonder lies in knowing that it is there at all, that for the first time the universe may have spoken back. And yet, for all the allure of the signal hypothesis, another possibility lingered with equal gravity. What if the glitch is illusion? What if there was no intention, no messenger, no code hidden in light, only the stubborn truth that the universe is stranger than our mathematics has yet admitted? To accept illusion is not to embrace failure. It is to recognize that nature itself is unfinished in our understanding. Perhaps Atlas was not speaking, but rather exposing fractures in the very fabric of physics, reminding us that the cosmos is older, deeper, and more complicated than the equations we hold sacred. If the distortions were illusion, then they may be the product of space-time itself, small-scale irregularities, quantum fluctuations writ large, or turbulence in the unseen scaffolding of the vacuum. Just as a mirage bends light into false pools of water, so too might hidden properties of the void bend photons into phantom grids and repeated harmonics. We would not be seeing a signal, we would be seeing physics in disguise, revealing its incompleteness. In this interpretation, Atlas is not alien, but accidental. It is a shard of ordinary matter, rock, dust, or ice, whose passage through space intersected with fields or domains we do not yet understand. Its silence in radio, its blank spectrum, its errant trajectory, all of these might stem not from intention, but from phenomena yet unnamed. And that, in its own way, is just as profound. For if Atlas reveals illusion, it tells us that the universe is not the smooth, comprehensible stage we once believed. It tells us that our models are provisional, our instruments partial, our certainty fragile. The glitch then becomes not a voice, but a mirror, reflecting the unfinished state of science. Some found comfort in this view. To believe in illusion is to remain within the realm of physics, to keep the conversation bounded by natural law. Others found it equally unsettling, for if the glitch is illusion, then it whispers of forces and fields we have not yet charted, structures of reality that elude even our most powerful theories. It would mean that human knowledge is still a child, scratching at the edges of a vast tapestry woven from rules we cannot yet articulate. And there is a different kind of terror in that, for if the glitch is illusion, then the universe may forever remain beyond our grasp, not because it hides a signal, but because its true nature is infinitely complex. The message, then, is not from another intelligence, but from reality itself. You do not yet understand me. You may never fully understand me. To see Atlas as illusion is to be humbled, to be reminded that science, for all its triumphs, is still provisional, that every equation may one day be rewritten, every certainty overturned. Atlas, then, would not be the voice of the other, it would be the silence of the cosmos itself, reminding us how much we do not yet know. And perhaps that is the greater wonder, that even in illusion, even in error, the universe remains a mystery vast enough to humble every attempt to explain it. By now, the debates had circled so many times that exhaustion itself became a kind of conclusion. Yet beneath the fatigue lay a deeper recognition, one that settled across observatories and lecture halls like a shadow. Whatever Atlas is, it forces us to face our own fragility. If the glitches are real, if they are signals, engineered and deliberate, then humanity is no longer at the center of the cosmic story. We are not the sole bearers of intelligence, not the only architects of technology. We would be children in a galaxy already touched by older minds, older hands, perhaps civilizations that scatter messages across the stars the way we scatter satellites into orbit. In such a case, Atlas is not merely an anomaly. It is proof that we are not alone and that we are latecomers to a conversation already in progress. If, on the other hand, the glitches are illusions, then Atlas is still no less profound. For illusion means that the universe itself is stranger than we imagined. It means that the physics we trusted is provisional, that our instruments are only partial mirrors of reality, reflecting fragments but never the whole. Atlas would then be a reminder that science is not the final word, but an unfolding story, and that the cosmos will always remain one step ahead of comprehension. Either way, the consequences are staggering. If Atlas is artificial, then we must ask who sent it, and why, and what it means for our future. If Atlas is natural but inexplicable, then we must admit that reality is still unfinished in our understanding, and that the quest for knowledge will never be complete. In both cases, certainty crumbles. Humanity, for all its ambition, stands humbled before the unknown. And this is the true gift, or perhaps the true terror, of Atlas, that it collapses the illusion of safety. For centuries, we believed the universe was knowable, that each mystery would dissolve beneath the lens of science. But here, drifting across the sky, was an object that refused to be solved. An object that reminded us how thin the walls of certainty truly are. In that sense, Atlas is not only a visitor from beyond the stars, it is a visitor from beyond certainty. It forces us to accept that mystery itself is a permanent feature of existence, that the universe is not obliged to answer our questions. Whether signal or illusion, it leaves us with the same truth. We are standing on shifting ground, surrounded by silence that may be speaking, or by noise that may be meaning. What Atlas forces us to face is not simply the unknown, it is the humility of not knowing, and the courage it takes to look into that silence and keep listening anyway. In the end, all that remained of Atlas for most of humanity were the photographs, those blurred, faintly distorted images archived in databases and journals. They were not beautiful in the way nebulae are beautiful, nor dramatic like the spirals of galaxies. They were modest, a small speck of light crossing a field of stars. And yet, within those specks lay a haunting weight. The distortions, the faint lattices, the doubled silhouettes, the ghostly ripples turned those photographs into relics, artifacts, of a moment when the universe revealed something it refused to explain. Astronomers studied the images long after Atlas slipped back into the dark. They ran algorithms across the pixels, enhancing contrast, searching for order. They compared them to simulations, to known error profiles, to patterns generated by cosmic rays. None aligned perfectly. The anomalies lingered, stubborn as scars. Each time they were revisited, they seemed to whisper again, "You saw this. You cannot unsee it." For the public, the images became symbols. Journalists reproduced them in articles. Headlines spoke of the third interstellar visitor, and documentaries lingered on their strange distortions. To many, the photographs were proof not of knowledge, but of mystery, a reminder that even in an age of supercomputers and space telescopes, the universe still withholds its secrets. To those who captured them, however, the images carried something more personal. They were not just data points, but memories of sleepless nights, of whispered arguments, of moments when science brushed against the edge of awe. The glitch was not simply a feature of the photographs, it was a feature of the experience, a fracture in certainty that could never be erased. The final frames of Atlas, taken as it dimmed and drifted beyond the reach of even the largest telescopes, are haunting in their simplicity. A fading dot, distorted and fragile, swallowed by the immensity of space. Nothing dramatic, no grand revelation, just a reminder that sometimes the greatest mysteries vanish quietly, leaving behind only traces and questions. And so the photographs remain, preserved in archives, printed in papers, shared across networks. They are relics, not of what was explained, but of what was not. Relics of an encounter with a visitor that may never return, a visitor whose truth slipped through our grasp like water through fingers. Perhaps, centuries from now, someone will revisit them with sharper tools, or with a mind capable of seeing what we could not. Perhaps the glitch will be decoded, its meaning revealed, or perhaps it will remain forever, a question, an echo of something we glimpsed but could not hold. The lingering image of Atlas is this: a faint distortion, a ripple of light against the dark, neither confirmed nor denied, neither signal nor error, but something in between, a cosmic relic suspended in uncertainty. And in that uncertainty lies its power. For the photographs of Atlas are not just records of an object, they are monuments to mystery itself. And then, at last, Atlas was gone. It slipped into the dark as quietly as it had arrived, fading beyond the reach of telescopes, swallowed by the ocean of interstellar night. No final blaze, no unmasking revelation, just retreat, steady and indifferent, as though the entire spectacle had been nothing more than a shadow passing across our vision. Yet the silence it left behind was louder than thunder. For the mystery did not vanish with the object. It remained, embedded in photographs and data streams, in the arguments of scientists and the restless imaginations of all who had dared to ask what it meant. Atlas had arrived without warning, whispered of impossible patterns, then departed, leaving only questions that may never be answered. It was not knowledge it gave us, but doubt. And perhaps that was its greatest gift. To some, Atlas will always be the shard of interstellar stone that revealed the fragility of human perception, a glitch that exposed the cracks in our instruments and reminded us of the limits of sight. To others, it will forever remain a messenger, a probe carrying intention, its distortions the first words of a conversation begun long before we learned to listen. Both interpretations haunt, and both are incomplete. What Atlas forces us to accept is that the universe may never yield all its truths. Some mysteries are not puzzles to be solved, but mirrors held up to remind us of our own smallness. Whether signal or illusion, deliberate or accidental, Atlas taught us that certainty is a luxury the cosmos does not offer. It gave us the image of light fractured against darkness, and asked us to decide whether we saw chaos or design. And so humanity is left with silence. Silence not of emptiness, but of depth. Silence that stretches outward, inviting, unsettling, eternal. Atlas has vanished into it, but the questions remain, echoing not in space but in us. For in the end, perhaps that was always the point. Not to answer, but to awaken. Now the narrative softens, as the voice lowers, as if the camera of imagination drifts backward through the stars. The pace slows, words drawn out like breaths in the quiet between heartbeats. The rush of theories fades, the tension eases. What remains is the stillness of night, the silence of infinite sky. Imagine the object now, a faint ember adrift, slipping farther from the sun, farther from every human eye. It drifts past the outer planets, past the Kuiper belt, into the unseen corridors of deep interstellar space. Around it stretches the velvet dark, pierced only by the thin starlight of 1,000 suns. The distortions it once revealed lie dormant now, invisible to us, carried away like secrets too heavy to remain. Perhaps it was only stone, fractured by chance. Perhaps it was something more, a fragment of another mind's intent. But as it recedes, those questions dissolve into the larger truth, that we are small beings on a small world, yet still capable of wonder. That the universe, vast beyond comprehension, still has the power to move us not only with beauty, but with mystery. Let the questions rest, then, like ripples fading on water. Let the silence expand until it becomes comfort, not fear. The The stars remain above us, steady and patient. The universe is not required to explain itself, and we are not required to solve it all at once. Close your eyes, breathe slowly. Picture the interstellar night stretching beyond measure, and within it, a single object drifting endlessly, carrying with it the reminder that not everything must be understood to be felt. The story fades now, softly, gently, into the silence. Sweet dreams.